this is Victoria again, and we just finished solving the system of equations. We found that x equals to -1 and y equals to 1. Now this is kind of fun, but let's think of another way that we can solve for this. Because what I love about math is that, of course, there's probably usually only one right answer for certain things, but there is not necessarily one right way to get the answer. So here's another way that we can find it. So we can look at these two equations and try to only see the coefficients in them. So here we have 1 in front of x, 2 in front of y, 2 in front of x, 3 in front of y, and we have 1 and 1 for each of these. So let's just create something that I'm going to call a matrix that consists of these two equations. So usually a matrix have these sort of square brackets around them. And so now I have 1, 2, 2, 3, and then because there's an equal sign, we're just going to use sort of like a little division or divider there. I'm going to have 1 and 1. So this is what our matrix looks like. And a process that we can take towards solving for x and y is to try to find a way that each column only has one row which represents 1x, and another column has one row which represents 1y. And after moving things around, we can get what x and y equal to very easily. So I would like for the top row to solve for x, and I would like the second row to solve for y. Okay? And so this is where x is, and this is where y is, right? We get, so the top row stays constant, stays the same. So let's make sure we go ahead and write it as it was. Okay. And the bottom row now becomes, so 2 minus 2 times the top row. 2 minus 2 times 1 equals 0. And 3 minus 2 times 2 equals -1. Okay, then we draw this dotted line, and 1 on the top stays the same, but then in the bottom we have 1 minus 2 times 1. That'll give us -1. Okay, see, so we're getting closer. And remember earlier we said that we wanted the bottom row to solve for y, while the top row solves for x. So we also need to find a way to make this 2 on top, make it to turn into a 0, so it's only solving for x. So how can we do that relative to the bottom row? Well, first, it might help to turn the bottom row into a positive. So we're going to multiply it by -1, just so that once we do solve for y, we don't have to worry about the negatives in that situation. So when we do that, we'll get 1, 0, 2, 1, 1, 1. Okay. And then to get this to be 0, we have to take 2 minus the bottom row. And that will lead us to getting this this still gives us the same representation of the same visuals of the same matrix. It's just the numbers are different proportion. They're the same proportion, but just different numbers. So since the bottom row has 0, subtracting 2 times 0 from the top row is not going to have an effect in the first column. Okay, and then the bottom row stays the same. So the top row, which is 2 minus 2 times the bottom row, which would make it 0. Dotted line, and then we have 1 here, and then 1 minus 2 times 1 equals negative 1. This is look familiar to you? Remember this? We found that x equals to negative 1 and y equals to 1. And here, remember that this column represents x and this column represents y. And so we find that so 1x plus 0y equals negative 1, and 0x plus 1y equals to 1. So you figured x equals to negative 1 and y equals to 1. Great, so we have just solved a system of equations, and we use 2 different methods. The first is the basic algebraic one, and this one is the linear algebraic one. And so 2 ways to get to the same answers. But if you're looking at this video, you're probably taking a course in linear algebra, so the majority of your problem solving throughout this course will involve things called matrices. Okay, so let's go ahead and define what matrix is.